What we're looking at today is how to take a line plot that has fractional parts in it and interpret the information in such a way that we can answer the questions that are being asked of us. Okay, so let's take a look at this line plot. We've got a line going across. We have 1, 2, 3, 4, 5 different fractions. 1/6, 1/4, 1/2, 2/3, and 3/4 that are listed across the bottom. And then above each fraction is a mark that shows us that's where that fraction goes along our number line. And then we have X's above each one. So let's read what the story tells us. It says that the candy shop sells taffy by the foot. Most people only buy a fraction of a foot. This line plot shows how much taffy was sold this week. So we can tell from the story that if you went into the store and wanted to buy some taffy, you would buy it in terms of how many feet do you want, or how much of a foot of taffy would you like to have. So by looking at this table, we can see, this line plot, we can see, okay, well, since there are two X's above 1/6, we can say two people came in and bought 1/6 of a foot of taffy. 3 people came in and bought 1/4 of a foot of taffy. 1, 2, 3, 4 people came in and bought 1/2 a foot of taffy. 4 people came in and bought 2/3 of a foot of taffy. And then 1 person came in and bought 3/4 of a foot of taffy. So we can see the taffy that was sold this week was broken up into these fractional amounts that represent how much of a foot they chose to buy. So the first question that we're asked is, which fractional amount of a foot sold the most taffy this week? So that's kind of a different question. In the past, we would usually be asked something like, which length of taffy sold the fewest amounts, or something like that. And we'd say, oh, well, there's just 1 X above 3/4, so 3/4 sold the least. But that's not what this question is asking us. We can't just look at the X's and figure out the answer. It says, which fractional amount of a foot sold the most taffy? So what we're trying to figure out is, when people bought 1/6 of a foot, since they sold 2 of those, did that add up to be the most taffy that was sold? Or was it 1/4? If we combined all of those 1/4 of a foots that were sold, would that end up being the most taffy that was sold? Or would it be 1/2? Or would it be 2/3? Or would it be 3/4? So we're trying to figure out which grouping, if we were to take that taffy and lay it out, which one would have ended up giving us the most taffy? Which one would have been sold the most? Right? So what we have to do is go through and add it up. So let's see, if we add this up, what we get. Okay. Well, I know that 1/6 plus 1/6 is 2 of those. And if I add up the fourths, 1/4 plus 1/4 plus 1/4 is 3/4. 1/2 plus 1/2 plus 1/2 plus 1/2. That's 4 halves. I realize it's an improper fraction, but I'm going to hang on for just a minute. And then I have 1, 2, 3, 4 of these 2/3. So I know the 3 is going to stay the same on the bottom, but I've got 2, 4, 6, 8. That was 8/3 that were actually sold here. And then 3/4 is just 3/4. Okay. So here's what I'm looking at. To answer this first question, I'm trying to figure out which one of these results in the longest amount. Which one was the most taffy out of all of these? So when I look at them, there's a couple of things that jump out at me. The first thing is that I have 2 fractions that are exactly the same. So there's a tie there. And then I also notice that I have 2 fractions that are improper fractions. So let me change those to mixed numbers and see what I get. I know that 4 over 2 means 4 divided by 2, and 4 divided by 2 is 2. So the 1/2 foot lengths of taffy that were sold added up to be 2 feet worth of taffy. But the 8/3, 3 goes into 8 twice, and that leaves me with 2/3 left over. So I actually sold, the taffy shop or the candy shop sold more in the 2/3 of a foot than in the 1/2 foot strips. So when I look at this, 3/4 is a regular fraction, proper fraction. It's smaller than a whole. So that means these are not the ones that sold the most taffy. 2/6 is not. That's way less than a whole. And 2 is less than 2 2/3. So in order to answer the first question, looking at this, I would say that 2/3 was the fraction that I guess you could say it was the most popular. When people came in and wanted to buy taffy, more people, when they bought the 2/3 of a foot, when you add all that together, that sold more taffy than any of the other fractional parts. So to answer part A, we would say that the 2/3 sold the most taffy. All right? But what about the second one? Part B says, what was the total amount of taffy that was sold this week? Now I got to go back. I've got to actually add all of this up together. And when I look at it, I see that for me there's kind of a problem. Because what I notice is I have 2 over 6, 3 over 4, 4 over 2, 8 over 3, and 3 over 4. Well, I can't add fractions that have different denominators. I have a 6, I have a 4, a 2, and a 3, and then the other one is also a 4, so I don't have to worry about that one. I've got 4 different denominators. I need these denominators to be all the same. There's a couple of ways that we could do this. I could go through and I could start trying to use the method that we've used this year, where we cross multiply, where we would say 1 times 4 and 6 times 1 and 6 times 4. And I could go through and do that. But the problem is I've got 1, 2, 3, 4, 5 fractions that I have to add together. And every time I cross multiply 2 of them, my numbers get bigger. And they get bigger and they get bigger and they get bigger every time I have to multiply. And so it kind of gets to be a problem. If I'm not careful, my numbers end up getting so big that it gets hard to work with. So the easier thing for me to do is to find a common denominator that I can use across all the fractions. So what I've done over here in green is I've created a T-chart, and what I'm going to do is just skip count by these numbers until I get to one that they all share in common. And the first one they share in common is going to be called the least common multiple, and that'll be my least common denominator. A good tip is to start with the bigger numbers because you can cover more ground faster. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. We'll stop there and see what else I can come up with. 4 times 1 is 4, 4 times 2 is 8. Okay, 8 times 3 is, let's see, 4 times 1, 4 times 2, 4 times 3 is 12, 4 times 4 is 16. And then I'm going to skip over and do 3's because it's easier to do the bigger numbers first. So 3 times 1 is 3, 6, 9, 12. And I see already that I have a 12 here, a 12 here, and a 12 here. And 12 is an even number, and any even number is a multiple of 2. So I know that if I were to skip count by 2's, I would eventually end up getting to 12. So 12 is going to be a common multiple of all four numbers. That means I can use 12 as a common denominator for my fractions. Okay? So what I'm going to do is I'm going to go back and revisit. I just added up all of these fractional parts and figured out that I had 2 over 6 here. And I had 3 over 4 here. I don't want to have them scratched out anymore because I'm about to use them. And then here, I had 4 over 2, and I had 8 over 3, and then here I had 3/4. Okay, so what I'm going to do now is I'm just going to go back and I'm going to change all these fractions into something over 12. That way I have a common denominator between them. So this one is going to equal something over 12. And anytime we are making equivalent fractions, you look at how did you get from 6 to 12, you multiply times 2. That means you're going to do the same thing up here. In order for it to be equivalent, you've got to do the same thing. Okay? So here, I want to make this equivalent to something over 12. So I've got 4 times 3 equals 12. So 3 times 3 equals 9. And then I want to do that for my 4 halves. I have 4 over 2, 12 times, or 2 times 6 is 12. So that's going to make 4 times 6, which is 24. And then I have 3/8. Needs to be something over 12. And 3 times 4 equals 12. So 8 times 4 equals 32. And then I already did 3/4. And I know that 3/4 is equal to 9/12. Okay? So this looks a little sloppy. So let's move up and let's fix this real quick. So I have 4/12, and I have 9/12, and I have 24/12, and I have 32/12, and I have another 9/12. Each one of these fractions represents what was down here. My 2/6 is now been rewritten as 4/12. So each one of these fractions represents the total amount of the fractional parts of taffy that were sold, and I'm looking for the total, so all I got to do is add these together. And because they have the same denominator, I know that when I get finished, my denominator is going to stay 12. I'm just trying to figure out how many 12ths I actually have. So I got to add all this up, and I have 4 plus 9, which is 13. So I've got a 13, I've got a 24, I've got a 32, and another 9. It's a bunch of numbers to add up, but it's not that bad. The numbers aren't that big. So I can add this up pretty quickly. 11, 12, 13, 14, 15, 16, 17, 18, 2, 3, 4, 5, 6, 7. So that's kind of a big number, 78 over 12, but that is not that hard for me to do. Improper fractions, 78 over 12. So I just need to do the division. I'm going to say 78/12 is the same thing as 78 divided by 12, and I just need to figure out how many times 12 will go into 78. Well, if I think about my 12 times tables, I know that 12 times 6 is 72, and I know I'm not going to get any closer than that. I do my subtraction, I'm left with 6. So 6 and 6/12 is my answer, but 6/12 is not in simplest form. 6 over 12, I know 6 is half of 12, So that simplifies to 1/2. So my answer is 6.5. So to go back and look at the original question, which was, what was the total amount of taffy sold for the week? It was 6.5 feet. 6.5 feet of taffy were sold. Okay? So this is how you solve the problems to this, the questions to this problem. And then the other part of your homework is another problem similar to this. So work that one on your own and see how you do.